Hi everyone. In previous video, my screen is not visible. I didn't share my screen. I forgot to share my screen. But my voice is audible. I checked. I will repeat the same content now. Application of K-means algorithm. K-means algorithm is very popular and used in variety of applications such as market segments, document clustering, segment clustering, image segmentation, and image compression. The goal usually when you undergo a cluster analysis is either get a meaningful intuition of the structure of the data we are dealing with. Cluster then predict where different models will be built for different subgroups if we believe there is a wide variation in the behaviors of different subgroups. An example of that is clustering patients into different subgroups and built a model for each subgroup to predict the probability of the risk of having heart attack. In this post, we will apply clustering on two cases. Geyser eruption segmentation 2D dataset image compression. Image compression is used in variety of example of business cases in real life like academic performance, diagnostic segment systems, search engines, wireless sensor networks. In evaluation method, later I will come for evaluation method. In evaluation method, in previous video I talked about evaluation method, but I didn't talk about elbow method and Silhouette analysis. Now I will detail explanation on elbow and Silhouette analysis. In evaluation method, contrary to supervised learning, where we have the ground truth to evaluate the model's performance, clustering analysis doesn't have a solid evaluation metric that we can use to evaluate the outcome of different clustering algorithms. Moreover, since the k-means requires k as an input and doesn't learn it from data, there is no right answer in terms of the number of clusters that we should have in any problem. Sometimes domain knowledge and intuition may help, but usually that is not the case. In the cluster predict methodology, we can evaluate how well the models are performing based on different k clusters, since clusters are used in the downstream modeling. In this, we will talk about elbow method and Silhouette analysis. Elbow method. What is elbow method? Elbow method gives us an elbow method gives us an idea on what a good k number of clusters would be based on sum of squares distance SSE between data points and their assigned cluster centers. We pick k at the spot where SSE starts to flatten out and forming an elbow. We will use the Geyser dataset and evaluate SSE for different values of k and see where the curve might form an elbow and flatten. For Silhouette analysis can be used to determine the degree of separation between cluster for each sample. Compute the distance average. Compute the distance average from all data points in the same points. Compute the average distance from all data points in the closest cluster. The formula is S equal to B power I minus A power I divided by max into A power I comma Bi. The coefficient can take values in the interval -1, 1. If it is 0, the sample is very close to the neighboring cluster. If it is 1, the sample is far away from the neighboring cluster. neighboring cluster. If it is -1, the sample is assigned to the wrong cluster. If it's 0, it's neighbor, very close to the neighbor. It's +1, it's far away from neighbor. It's -1, it's wrong cluster. Therefore, we want the coefficient to be as big as possible and close to 1 to have a good cluster. We will use Kaiser dataset again because it's cheaper to run the Silhouette analysis. It is actually obvious that there is most likely one to group of data points. In other words, this formulator considering both the intra and the inter-cluster distance for given point xy for the average of the distance to all points in the same cluster is calculated. This value is set to ai, then for each cluster that does not contain xi, the average distance of xi to all the data points in each cluster is computed. This value is set to bi using these two values. The Silhouette coefficient of point is estimated. The average of all the Silhouette in the dataset is called the average Silhouette for all the points in the dataset. To evaluate the quality of a clustering, no one can compute the average Silhouette coefficient of all points. It's in other words, it is the words of from my knowledge. The same formula, such as here S equal to summation of n bottom I is equal to 1, b I minus a I divided by max a I comma b whole divided by n. It is also same. The both are same. Both are not different from each other. Silhouette analysis is very, very important. Next, drawbacks of K-means algorithm. K-means algorithm is good in capturing structure of the data. If clusters have a spherical-like structure shape, it always try to construct a nice spherical shape around the centroid. That means the minute the cluster have a complicated geometric space shape, K-means does a poor job in clustering the data. We will illustrate the three cases where K-means will not perform well. First, K-means algorithm does not let a data points that are far away from each other share the usually belong the same cluster. Below is data on two different horizontal lines line the illustrate. First, I already told horizontal line for person doesn't let data points that are far away from each other share the same cluster, even though they obviously belong to the same cluster. For second, we will generate data from multivariate normal distribution with different means and the standard variation. So we would have three group of data where each group was generated from different multivariate normal distribution. Different mean divided by standard variation. One group will have a lot more data points than the other two combined. Next, we will run k-means on the k is equal to 3, and if it is available, if it will be able to cluster the correct data correctly, to make comparison easier, I'm going to plot first the data colored based on the distribution it came from. Then I will plot the same data. K-means clustering algorithm supports various kinds of distance measures such as Euclidean distance measure, Manhattan distance measure, a square Euclidean distance measure, and cosine distance measure. Euclidean distance measure. The most common case is determine the distance between 2 points. If we have point P and point Q, the Euclidean distance is an ordinary straight line. It is the distance between the 2 points in Euclidean space. Squared equidistance measure. This is identical to the Euclid distance measure but does not take the square root at the end. Manhattan distance measure. The Manhattan distance is the simple sum of the horizontal vertical components and the distance between 2 points measured along axes at right angles. We are talking the absolute values so that the negative values do not come into play. The last cosine distance method is, in this case, we take the angle between the two vectors formed by joining the origin point. Thank you. That's all for my information. I prepared this for K-means clustering algorithm, and thank you.